Okay, guys, so the next lesson is going to be on symmetry. So we kind of already have a good intuition, perhaps, for what symmetry is, but usually we think of symmetry through the idea of the reflection or mirror image, like what we saw in 9-1 reflections, right? So that kind of symmetry is called line symmetry. So basically, if I have an example here, which is if I draw a line somewhere such that the image on one side and the other side are mirror images of each other. So I think the natural place to draw the line maybe would be here, okay? So that if you have a point that's, let's say, I don't know, 2 units over to the left, you'll see another point that's 2 units over to the right, something like this, okay? Maybe that's only 1 unit, but you get the idea, is that if you could draw a line such that there is symmetry over that line, so like if you fold the object over itself, it will coincide with the other side of that line, okay? So that's line symmetry. It's a pretty simple one. The next one we're going to talk about is called point symmetry. So point symmetry is if an object looks the same upside down, then it has point symmetry, right? So you could take a look at this letter N, and if you sort of flip your paper upside down, then the N looks pretty much identical to what the original N looked like, okay? So that's the idea behind this one, and I can kind of demonstrate that. Let's see if I could demonstrate that. If I kind of highlight the shape for the N, let's see. If I do that, and then maybe I can rotate this object. Let's see. Could I rotate it? Yeah, maybe rotate. We could start with 90 degrees and then do another 90 degrees. And then what you see is that it's virtually identical to the highlighting that I had started with, right? Maybe a tiny bit off, but you get the idea, okay? So if it's the same after a rotation of 180 degrees, in other words, it's the same upside down, that's called point symmetry, okay? The next kind of symmetry we'll discuss is called rotational symmetry, okay? So here we have a figure, and it has rotational symmetry if it is the same after a certain number of degrees of rotation. So in this case, this figure does have rotational symmetry because if you notice, the features repeat themselves after you turn by some number of degrees. So when we have a rotational symmetry in a figure, we always want to figure out how many degrees can I rotate by in order to get the picture to be the same. So the way to figure that part out is you have to count how many of these features are there that repeat. And if we count these blue lines I've drawn, I have 1, I have 2, 3, 4, 5, 6, 7, 8. So notice that this has 8 repeating features, okay? So if we have an object that has 8 repeating features, okay, then what we would do to figure out the minimum angle of rotation needed is we would take 360 divided by 8, okay? And in this case, what would that equal? I think 45 degrees, okay? So in this case, yes, you would always do 360 and then divide by the number of repeating features that you have, okay? So we'll see a bunch of examples. But this is basically describing the minimum angle of rotation that is required to get the figure to look the same. So if I rotate this by 45 degrees, which happens to be the distance between those two blue lines, then I will get the exact same figure showing up, okay? So let's try some examples. So let's see what kind of symmetries that this object has. Does it have line symmetry? I think so, because I could just draw a line down the middle. You may have also drawn a line this way, okay? So it definitely has line symmetry. Now, does it have point symmetry? So does it look the same upside down? I would say it absolutely does. Now, notice that if an object has point symmetry, then it automatically has rotational symmetry, right? But now we also want to figure out how many degrees of minimum rotation we would require for the object to look the same. So the question becomes, how many repeated features does this have? And to me, these sides could be thought of as a feature. And if you count the sides, 1, 2, 3, 4, 5, 6, there's 6 sides, so that's 6 repeating features. And so if we do our trick, which is 360 divided by that number, then you'll get the minimum number of degrees after which you'll get the same figure. So in this example, you can kind of draw lines out to each vertex like this, and the degree measurement in between of here would be 60 degrees. So that means if you twist the figure by 60 degrees, it will end up looking exactly the same as what it did originally. Okay. Next one. So this one, what kind of symmetries do we see here? Well, do we have line symmetry? Let's see if we could find a line that would work. So if I choose this line, notice that this is short and this is long, so those are not mirror images of each other, right? Maybe if I choose a line slanted like that, maybe that would work. Let's see. This looks pretty good, right? So if I have a point that's a certain distance away, it'll appear over here a certain distance. Okay, so this is looking pretty good. Now, next one is point symmetry. So does this picture look the same if I put it upside down? Well, you could just flip your paper and check it out, right? I think so. Does it have rotational symmetry? Yes. And in this case, notice there's only two long sides here. So there's two long sides. Even though there's four sides, only two of them are long. So that's two repeated features. So actually we would do 360 divided by 2, and that gives you 180. So that is actually the same thing as the point symmetry, the upside down symmetry. Okay. Now if we look at the next one, what kind of symmetries does this have? I think it has line symmetry down the middle, like that. Point symmetry, if it's upside down, then notice that the star has got 2 points, right, facing up. So we could try that thing that we did before, just to check it out. But if I take this and rotate the highlighting, let's say I do 180 degrees, so 90 and then another 90. Notice that the 2 points are facing upwards, so that's not actually the same picture, right? So I would say it does not have point symmetry. Does it have rotational? Yes, it does have rotational, because it has a certain number of repeating features in a circular pattern, right? So if I find the center and I kind of go out to these repeating features, every time one of these star points upwards, that would be a repeating image. So I think that will happen 5 times. So if we do 360 divided by 5, you get 72 degrees for the rotational. Okay. And this letter A does have line symmetry down the middle. It does not have point symmetry because it does not look the same upside down. It does not have any rotational symmetry, so there's no features that repeat in a circular fashion. Okay. So now, guys, your turn to try the right-hand side, and I'll pause as you're working through those. So just pause the video here. Okay, so you had a chance to look at some of these, so let's check them out. Line symmetry, yes. Point symmetry, no. Okay, it does not look the same upside down. Rotational symmetry, yes. So it has 3 repeating features in a circle, right? 1, 2, 3. So 360 divided by 3 gives you 120 degrees of rotation to get that image to look the same. Okay, so next one. Does this have any line symmetry? I would say it does not. And does it look the same upside down? I would say no, and no rotational. So this has no symmetries. Okay, next one. Does it have line symmetry? Well, where do we draw the line, right? So shall I draw the line this way? No, because then this is supposed to fold over to here. And I can't draw it this way because then this is supposed to go here, right? So the only option perhaps is to draw it this way, right? But then I think we still don't have any type of good symmetry there. So I would say no to line symmetry. Does it look the same upside down? I would say yes. It only has the 2 repeating features, so 180 degrees is the angle for rotational. All right, and this one I think has no symmetry at all.